Okay, so now we'll be discussing some resources that if you plan to do some research in one of the areas of deep learning, then what are the good resources? So I hope all of you have taken the course on research methods, right? In which you are told that the, the most reputed and credible source, they are the good journals, right? Okay, so for deep learning, of course, there are many journals which I have listed a few of them, but of course you can list many more. So there's Journal of Machine Learning, then Neural Networks, IEEE Transactions on Pattern Analysis and Machine Intelligence, and so on, right? So these are, you can say, the top journals in which you should, not only you should read literature from them, you should also target them if you are doing research, right? That at the end of your thesis, you come up with a good paper and you target one of these. Okay, it's a bit optimistic, but if you can, if you work hard, you can always try one of these. Then, of course, we all know that it takes some time before something appears in a journal. Maybe if I have finished something today, it will take at least 1.5 year before it appears in a journal, right? So if you want recent information, recent means few months or less than maybe 6 months, something like that. So then, of course, we prefer conferences, right? Because that is a quick publication forum. So the top conferences in this domain, NIPS, ICML, CVPR, then we have ICCV International Conference and the British version and the European version of Computer Vision Conference, right? So these are basically the top conferences in, if you have to see papers of the giants of deep learning, so they will be in one of these conferences, right? They would never publish in something below this level. But there's another thing which I hope you already know, that you see it did not exist about a few years back, but it's relatively recent that there's something which is called archive, right? So I hope you know it. Even if you don't know it, what is it? It is basically a repository where you can upload your work in the form of a research paper or a technical report, right? It is not published just like a conference or a journal. It goes a very light review, and maybe once you submit, after few days it will be available online. Okay, so what happens is that since publishing something will take at least 6 months, publishing in a journal will take maybe 1.5 year. So when people do something, they quickly write a paper, and before submitting it to somewhere, they upload it on this repository. Okay, you as a researcher can search, you can cite this paper, it is a valid citation. The advantage is that you see there's a lot of competition in deep learning. Things are changing on weekly basis, if not daily. So if I'm thinking of a solution, maybe three other people are thinking about the same solution. Okay, and the solution belongs to the person who advertises it. You can say first of all three. So if I'm waiting for my paper to appear in a conference, maybe someone else already publishes, and then all the hard work that I have done, it will be of no use. So what people do these days, they quickly write a paper and they upload it on this repository. So this is actually like assigning a label that, okay, this is my work. So if someone else is doing, then they are late because you already upload it on archive, so it belongs to you now, right? Of course, there some people don't like it because not everything which is uploaded on archive is eventually published, right? You can also find some papers which are not of very high quality, but still it is, if you want very recent information, then you should not wait for a conference or a journal. You should directly go to archive, right? I think it has papers of computer science, physics. There are 3 to 5 domains. And once I last checked, the total number of articles in this repository, it was, I think, 1.7 or 1.5 million. So you see, this is a huge number. So if something you have finished today, you write its paper in 2 days and you upload it on archive, right? And this will actually assign a label to that solution. So conclusion of these 2 slides is that if you want latest work, like 1 week old, 2 week old, always go to archive and see that what new papers are being uploaded which are related to the problem that you are solving. Okay, next, before we move to the implementation guidelines, there's a small homework. I have called it homework 0 because it is so small that it does not qualify to be called homework 1, right? I will not check it. You don't need to submit it. It's just for you. That I would appreciate if you can go back and search a deep learning library, right? I told you few libraries like Keras, TensorFlow, PyTorch, but it would be good if you search for a library other than those which I have told you, right? So it's a good idea that you know the names of the libraries, because when you appear for a job interview, people can ask, do you know about this library? So even if you know the name, at least you have heard of it. You can say something on that, okay? And then I would also like that. You go back and search a benchmark deep learning database, right? Of course, other than those which I have shown you. Okay, so maybe if there are 23 students and everyone with some overlap, if every one of you come up with one database and one library, so at least we'll have 15 to 18 unique libraries and unique data sets, right? So in a regular semester, we used to make 2 slides for every student, in which every student would introduce a library and a database. But since we are in online mode, so that would not be possible, right? So this is just, you can say, an optional work. If you want to do it's good. Even if you don't do it, I won't be asking you for submission, right? Okay, so now the boring part is over, and now let's do something which is more exciting, right? At least for me. So that, you see, we can talk for hours and hours, but if we cannot implement it, then it's useless, right? So whatever we talk, whatever concepts we study, uh, initially there will be, you can say, 3 modes in which I'll be teaching you different topics. The first mode will be technical discussion. For example, if there's ANN, I will conceptually tell you what is ANN, okay? The second mode would be that we will numerically solve different problems related to the concept, like ANN. For example, if it's an ANN, I'll give you some numbers and you will solve by hand how the forward pass works, how the backward pass works, okay? And then once you have done that, then we will implement it by writing a computer program, okay? So maybe since we have many topics, so out of these 3 modes, at least 2 modes will be applicable to every topic, right? Maybe in some cases we skip the implementation, in some cases we skip the by hand part, okay? But at least 2 modes will be applicable to every topic. And what is the reason for that? You see, you must be knowing that today we have very high level APIs available. You can make a very complex neural network just by, say, 5 lines of code, right? So if it's back propagation, there is one function, model.fit, which is doing back propagation, right? But this is good from the viewpoint of developing quick solutions. But the downside is that many, not only students, many researchers, many students, and even many professionals, due to this ease of implementation, they just call the function, come up with a solution, but they actually do not know what is going on at the back end, right? Means you can make a very complicated neural network, but if you cannot tell how back propagation works, how weights are updated, okay, then of course you will never be able to come up with innovative solution. You will always just be changing parameters. You will download some code, play with the parameters, and somehow you will come up with a solution, right? But you will have no theoretical knowledge of how things are working. So that's why I will insist, at least in the first few you can say topics before the midterm, that everything we study, we solve it by hand, just like the numericals we used to solve in maybe school or college days, and then we'll implement it, okay? So of course, today we don't have any numericals to solve. We will directly see some guidelines on how you can install different libraries on your machine. I'm hoping that many of you already know this, right? But I'm not assuming that all of you know. So that's why, for completeness, I'll be telling you from the scratch, okay? So we already agreed that we'll be using Python, and I justified the choice for that, okay? So there are 2 options you can follow, okay? So if you are, you can say, very naive, you are just a beginner, you don't like programming much, then you go for option 1, okay? Although I would prefer option 2, but if this is the first time you are actually writing some programs, then you go for this option. So this is the easy way. What is the easy way? You simply download Anaconda, right? Which is a free distribution of Python. It has a graphical user interface, right? You just click on, maybe for example, you can click on this spider. It is like an IDE in which you can write your code. Then you also have a web-based, you can say, Jupyter. it's like a browser in which you can type your command, something like that, right? But this is one way, right? Although not the recommended way. And then when you are writing program, there are many packages that you will need. Okay, when you, for example, download Anaconda, Python is installed automatically, right, with Anaconda. But not everything that you need is installed. You need some additional packages, right? So if you need some additional package, what you will do is you will go to start, okay, and you will type Anaconda. So you see this is your Anaconda navigator, the graphical user interface, and you also have Anaconda prompt. Like this is just like the terminal that you have in Windows. So you can click on it, and here you can type commands. So whenever you have to install a package, you can type the command either conda or you can type the command pip. Okay, they are slightly different, but I'm not going into the detail. And the syntax is that you write pip or conda install and then name of the package. What package? For example, maybe NumPy, SciPy, scikit-learn, TensorFlow, and so on, right? So anything you need to install, you simply open this Anaconda prompt, you write pip install, and here you write the name of the package, and it will be automatically installed. Of course, you need to be connected to the internet because it will be downloaded and it will be installed. Okay, right. So that was option one, the easy way. Okay, but I would appreciate if you go for this option. Now, what is this option? That in this option, you don't have to install Anaconda, right? But what you install is something which is called Miniconda. What is Miniconda? It is just like you can say a prompt, okay, where you can type commands. But with this, you will not have all the additional package that you get with Anaconda. Okay. Now you can open a terminal window, right? And then what you do is you write this command. I'll tell you what is it. Okay. We are saying conda create new, and then I have written TensorFlow. I tell you what is it, and Python 3.8. 3.8 is, I think, the latest version of Python that is available these days. It keeps on changing, but I think 3.8 is the latest as of today. Okay, so what we are doing here, this is something which is called creating a new environment, right? So what we are trying to do with the command here, this command creates an environment. Now you might be thinking, what is an environment? Okay, environment is like a workspace. Okay, so when you create an environment, this is the name of the environment, what I have written, TensorFlow. You can give it any name. You can call it ABC, you can call it XYZ, you can call it whatever you like, right? This is your workspace, and we are also installing Python 3.8. So why do we create an environment? What is the advantage? You see, if you have a machine and different people are using it, right? There are different versions of Python. Maybe the code of Python 2.7 will not work on Python 3.8 and vice versa, right? So if you download a code which was written in Python 2 and you have Python 3 in your machine, so what you need to do, you will need to uninstall Python 3.8 and revert back to an older version, right? Some days later, you download another program which works on Python 3.8, so you will again have to do this. So when you make an environment, you can, in each environment, you can have multiple versions of Python and multiple versions of packages, right? For example, if there is NumPy or there is TensorFlow, so maybe TensorFlow 1 is something else, TensorFlow 2 is something else. You download some code which was written 3 years back. If you try to run it with the TensorFlow that is available today, it will not work. So it means that again and again, you will have to install different versions. So what you can do, you can create multiple environments, right? For example, you can have an environment in which you have Python 2.7. You can have another environment in which you have Python 3.8. And same you can do with like TensorFlow or NumPy or any other library. And the advantage is that whenever you have to execute a program which runs on a particular configuration, you just have to activate that environment, right? And how do you activate that environment? For this, you have this command, conda activate, and this is the name of environment. Okay, for example, if my environment name was TF, I will write conda activate TF. If my environment name was Python 2, I will write activate Python, say 2.7. Okay, and these environments do not interfere with each other. So you see, it's a very big advantage. On the same machine, you have multiple versions of Python, you have multiple versions of TensorFlow, and if you come across a code which works only on some previous version, you simply need to write one statement, activate and name of the environment, and then you don't need to do any installation or uninstallation, right? So for example, here is a screenshot of what I got once I activated this environment, right? So this is your terminal which comes with Windows. So I write conda activate TensorFlow. Now you see here, this is the environment. I can write something else, conda activate ABC, so it will go into that environment. But of course, first you need to create that environment, right? So this is something that I would prefer. If you do this, it would be relatively easier for you, right? Especially when you are writing some advanced program. Okay, so once you have environment, once you have TensorFlow, sorry, not TensorFlow, once you have environment, Python, now you will need to install something which is TensorFlow, right? Because we'll be dealing with that. So this is a command that I have listed, okay? Again, pip install. If there is some previous version, you can ignore it, right? And this is the version of the TensorFlow, which is 2.2, right? I think the latest is 2.3. Once I checked last week, but I needed 2.2, so I installed 2.2. Okay. Now, one thing is very important, which are the next two bullets. Okay. So previously you had TensorFlow version like 1.5, 1.7, and so on, right? And then you have TensorFlow 2 point something. Okay. So there's a very key difference between these two. In TensorFlow 1, you had two separate packages. One was called TensorFlow, the other was called TensorFlow GPU. It means if your machine has a CPU, you will install this. If your machine has a GPU, you install this. Okay. So the problem is that, suppose in my personal computer, I only have CPU, so I install this. Then I go to the university where there's a GPU, so it means there I need to install this. Okay, and again I will have to make some changes in my code. Not many, but still some slight changes in the code as well. The life is much more easier in case of TensorFlow 2, where you only need to install TensorFlow, and it will automatically figure out that if a GPU is available, right, it will use it. If it is not available, your code will be executed on CPU, right? So that is why I would recommend you that please do not go for TensorFlow 1. You should go for TensorFlow 2, because you only have one single version that works on CPU as well as GPU, right? So the programs that we will be initially making, for those you will not need any GPU, right? But if you are doing some thesis or you are executing a program on a CPU, it can take like a few days or even few weeks to run. Okay, of course you can run it on the cloud. I will tell you later how you can do that. But if you want to run it on your own machine and your own machine has a GPU, so I will give you some guideline, but not today, maybe at a later stage, right? Maybe around midterm, because if you want to run your code on GPU, you need some extra effort. What is that extra effort? There's a toolkit you need to install. You need to install Qt, and there's a lot of path setting. There are many paths that you have to set, right? So this whole exercise, if you have not done before, it can easily take 5 to 6 hours, right? If everything is smooth, of course, it will take 1 hour. But when we are doing configuration, normally things are not smooth, right? We always end up in some dead end and we have to revert back, right? So that's why for the time being, I don't want to frustrate you that you keep trying for the GPU version and you get frustrated. So that's why what I expect is that initially you only install TensorFlow, right? And you forget about this. Even if your code is running on the CPU for the first few weeks, that is perfectly fine. Okay, then you see, when we are going for Anaconda, we have an editor, we have an IDE. I can write my code here, okay? But once I'm going for this option 2, so then where will I type my code? It means what is the editor I use, okay? You can type your code in Notepad, but you see Notepad is not very friendly for typing code. It does not have any sense, so on, right? So there's a very lightweight, this is just a suggestion, I have a recommendation, you can choose anything, right? That you install Visual Studio Code. It is a very lightweight, you can say, editor where you can type your code. For example, this is a very simple hello world program in Python, right? This is a comment and this is a statement. So actually this allows you to write code in almost everything, C++, Java, Python, Perl, anything that you can think of, right? So you save it as a PY file, right? And then once you have to run it, you again go back to the terminal and you activate the environment, okay? And if you have to run some file, you simply give the command Python and name of the file, right? So Python is actually telling that you want to run a Python program, and this is the name of the file, and this is the output that you will get, okay? So let me just try. I think this file is still there. So just to convince you, I'll try and run it so that you are actually convinced that this actually works, okay? So let me just share the complete screen rather than just this window. Okay. Okay. Can you see my terminal? Um, I hope you can. Any one of you can type in the chat. Okay. Thank you. Okay. So you see what I need to do first. Activate. I have many environments. I am activating this one. TF 2.2, right? TF 2.2 because it is TensorFlow 2.2. I also have one. I also have 2.3. So that's why I have named them like this, right? You can name them anything you want. Okay, so now I have a file. Let me see where it is. It is somewhere here. Okay, so this is a file. Say, this is hello.py. Okay, I can open it. So you see just one line. Yeah, you can also open it in Visual Studio Code. Okay, so first I need to go to the directory cd. Okay, so now I am in the right directory, and I also have, you can say, the environment activated. So let me try Python. So you see, this is the output, hello world, because we just printed it. So this is the way you can actually do. Okay, I can also show you the code. Sorry, this is Visual Studio, not Visual Studio Code. So you can simply write this program in Visual Studio Code, and you can simply write this command to run the code. Okay, so this is the preferred way of doing it, right? But if you're not very comfortable with it in the beginning, you can simply install Anaconda, and that I would say is the beginner way of doing things. Okay. Okay, let's come back to this. Okay. So you see the next slide, I just thought maybe many of you already know, but we talk a lot about GPU, but at least you should know how GPU looks like, right? So this is one of the latest GPUs, right? NVIDIA E6000, okay? So you can buy it. It's expensive, like $2,000 to $3,000, right? But of course, there are some other channels through which you can buy it much cheaper. Okay, this is what a GPU is. It can either have a VGA or a HDMI slot, right? But definitely we don't use it for display. For display, you can use it, but you have a separate VGA card which is for display, and this you use mostly for computation, right? This is the fan. So if you are working in deep learning and you are using GPUs, at least you should know how it looks like, right? So if it was if it was a live class, I would have shown you in the class, right? But since I cannot physically show you, it's in the, so that's why I have just pasted a picture, right? Okay, so with this, you can say guide on implementation. What do I expect from you? I expect that when you come on next Wednesday, you have Python and all the required libraries. What are the required libraries? I had shown you NumPy and then TensorFlow and all that, okay? And then I have uploaded a quick tutorial, right? There's a link which is available on your Piazza web page, right? You see, it will not take you more than 1 hour to do it. You can skip the some of the later parts of this tutorial. Now, what is this tutorial? You see, we don't, the objective is not to make you a programmer. So we don't want that you start learning Python, you buy a book and you start at chapter 1 and you start writing program and then go to chapter 10. So this will take 1 year or maybe 6 months. We don't want that. The best way to learn programming is that you, if you have not worked in Python, or but you have worked in some other languages like C++ or Java, right? So it's only the syntax that differs, right? So the building blocks of any programming languages are like selection structure, if else, and you have repetition structure, loops, how you make functions or routines or whatever you call them, depends on the programming language. So this is a very crash sort of tutorial, which will give you some building blocks, okay? And you can put those blocks together to write meaningful programs, okay? And of course, as I told you, I don't want you to memorize names of functions or memorize the commands, right? Because whenever you have, once you have this basic knowledge, if you have to make a program and you don't remember how to compute square root in Python, you can always look up, you can always search it, right? Maybe in C++ is sqrt, so you don't know what is it in Python, you can always look for it. But if your basics of programming are good, you know that when you call a function, there is something called an argument, there is something which is called a return value. So the same concepts are replicated with different syntax across multiple languages, right? So I would appreciate if you could go through this tutorial. The link is available on Piazza page. You can skip the later parts of the tutorial. It has all the necessary components which will help you write complex programs at a later stage. Okay, finally, there's something I would again appreciate if you do it right. So you see, whenever you talk of deep learning, you search for a code, you must have noticed that you find it on GitHub, right? So again, I'm assuming that with the knowledge of machine learning, you must be familiar with what is GitHub, what is Git, right? But I'll just in a couple of slides quickly tell you, right? I'll not go in much detail. So if you make an account on GitHub and you have a good profile there, so it really helps, especially if you are looking for some career in data science, right? So those of you who have done professional software development, they must be knowing that there's something called a version control system, right? So when you are working in a team, so different members of the team are working on different parts of a program, right? So it's not like that, that if I have written a file, you need that file, I will email you, or I will copy that file in a flash drive and then run to your desk and give you, right? There are proper tools available which are called VCS, versioning control system, right? Which allow multiple members of a team to work together collaboratively. And if I'm making some changes, you are making some changes. So these tools make sure that the changes are not overwritten. And they also maintain a history of different versions so that you can always revert back that, okay, I want the version which I had 1 year, or sorry, not 1 year, maybe 1 week back, and so on, right? So when we talk of version control system, there are centralized as well as decentralized system, right? So as you can guess from the name, centralized system is basically a central server which has all of your files, right? But you can guess the drawback is that there's a single point of failure. If the central server is down, you cannot do anything, right? You have to wait before the central server is up again. And in case of a distributed version control system, every client also has a mirror of the repository. Means you have the files on a central server, but you have the complete repository mirrored at each of the clients, right? Even if the server is down, the client can always copy back data to the server. So there is no, you can say, problem of single point failure. Now, with that, you see, when we say Git, it is actually tool. It is actually a distributed version control system, right? Uh, the idea I explained you in the previous two slides, okay? And when we say GitHub, it is actually remote storage, a cloud-based storage for repositories. Means GitHub is actually the storage where you are hosting all of your profile, all of your code, all the version, and then Git is the tool which is actually the version control system, right? So you see, there are many options. You can have different, if you have a main program, you can have different branches, different versions. You can always pull, you can always share, and you can always update your code using different commands, right? If you are using Git, you can type commands, or there's also a user interface, graphical interface. If you don't like to type commands, you can always use that, right? So again, I don't expect you to mandatorily make some profile on GitHub, right? But if you do that, it will help you maybe sometime in the future, right? So whatever program you make, you can put them on the GitHub. If initially you are shy, you don't want to make your profile public, there is always the possibility of a private profile, right? You can make a private profile, you can share it with, I think, 2 or 3 collaborators. So that will not be publicly available. And once you mature, you can actually make your profile public. Okay? And just to give you an idea that you see how the people around the globe have been using GitHub. So you see a major concentration in this part, which is you see a major you can say concentration of users in this is like the United States, this is the Europe, right? So you see a lot of people have been using GitHub for sharing of you can say resources, right? We don't have too bad a situation in this part. It is pretty okay. Slightly surprising is that we don't have much representation from China, right? But you see, mostly this is the UK part, and this is rest of the Europe. So you have very dense, you can say, dots, which represent a very major proportion of the population that is actually actively using Git and GitHub. Okay, and for this PPT, the last piece of advice, right, is that again, something from Albert Einstein, that the only source of knowledge is experience, right? In the context of this course, how can you correlate by experience? I mean by writing program, by solving numericals. Okay, so it's good that you listen to 3 hours of speech. That's good. You revisit the lecture many times, but unless and until you program and you do by hand whatever we are discussing, so that is the experience for this course. If, for example, if you do back propagation once by your hand, then I can bet you will not forget it at least for next 3 to 4 years, right? Because once you solve it each step, then it becomes clear. Okay, if you only see the equations on the slides or in a video, they seem to make sense, right? But you don't get the same kind of depth, right? So I would appreciate that whenever we are studying some topic, please do it numerically. Even if I don't give you an assignment, you can on your own take some hypothetical values, feed them to a network and see what is actually going on. Okay, and whatever knowledge you will acquire through this channel, that will persist for a much longer, you can say, duration as compared to just by listening to the lecture or by watching the videos. Okay, so with that, we'll stop this one, right? So if you have any points, any queries, please let me know.